Раз. Okay. Today we end of proof fundamental theorem of product, and the literal reminder of last time. Our goal is proof theorem the homomorphism mu from X tensor product of H factor to K X product S2 and isomorphism of ring for mu. Okay, and the statement we proved in the last time, proposition 1. Every vector bundle over X have form EF and EF is isomorphic EL, whereas L is Laurent polynomials. It's F is a map between E and E, and E is a vector bundle over X. Is a compact topological space. F is F is partial function. It's meaning it's a map between E from E to E and optomorphism in S1, and we is from E. Yeah. Okay. And yeah. vector bundle. P. P is a projection. E. Yeah. Mm. Yeah. Mm. Okay. Um, okay. L is a Laurent polynomial. Polynomial. Um, its meaning L have form mm, sum of A x that's n. Yeah. Mm? Yeah, sorry. Yeah. Oh. Oh. Yeah, yeah. I know right the proposition what we prove. Okay. Second proposition, what we proved in the last time is if Q is a polynomial clutching function. And the degree of Q less or equal n. We have when now we talk about just polynomial Cauchy function. Then EQ plus NE1, whereas meaning NE is some n times E. One is identity map. Equals 1 plus n plus 1 E ln Q, whereas ln Q is a linear Cauchy function. It's meaning Q has a form okay, this proposition we proved in the last time. No new proposition. Proposition 3. For every vector bundle E over X, E X Z plus B of X, where is a splitting or E E equal E plus E minus, and we have E X Z plus Bx equal E minus 1, and E plus 1 some E minus Z. Okay. Proof of this. Is first idea is define a homotopy between Ax Z plus B of X and Z plus B of X. So for doing this, consider the expression. 1 plus the Z if I open the brackets, we have okay. Now let's check if we take t equals 0, is equal with it's easy see. Let's go call with expression 1, expression 1, and expression 1 equal ax z plus b of x. We can see if t equal 1 isn't an automorphism, because if t equal 1, we have 1 plus z, and z lying in S1. But if t plus 1 is a automorphism, because it's with lie in S1. To see this, we can write a model for T0 and multiply by z conjugate z. It's equal 1 plus T0 z bar and you see with model of this equal 1. And we're just multiplying by some scalar. So when T0 less 1 is an automorphism. So let's see in right hand side, we can see a of x plus t b of x, and when t of t equal 1 is an automorphism, because it's some so if T0 lie near 1, using continuous argument, we can say is an automorphism. Yeah.
For example, the map x goes to ax is a homomorphism from R to R.
Yeah.
And then as a goes to 0, the map goes to 0, which is not
with automorphism because is a restriction a x t plus b a of x z plus b of x when z equal 1. And this meaning this expression is an automorphism. So we can write if E f g equal E f when G is isomorphism of E to E, and
G depends only on x and not on z. Is this correct?
Yeah.
But please write it down.
1 second. Okay. G is independent of z, and so let's take invertible of G for this, and we get after this z plus t0 a x plus x a x of x and we say is a new biofix, and we get homotopy. Okay, now we want in the lemma we have a splitting of E. So do the splitting, we need a lemma. Lemma. Let B is a map from E to E is an endomorphism. Having no eigenvalues on S1. Eigenvalues. And when when we're unique unique subbundles E plus and E minus, such that A E equals some E plus minus B is a invariant space. B plus minus lie in B plus minus, and let's say the eigenvalues eigenvalues.
It's a German word.
Yeah.
Well, at least the first half is German. The second half is English, but the first half is German. The first half is
Eigenvalues. Yeah. Of the restriction plus lie outside of S1. And restriction of B E minus the eigenvalues of B restriction E minus lie outside like inside S1.
When you say outside and inside, do you mean strictly outside or not strictly?
Strictly. B will be B having no okay. I wanna skip proof with lemma, and if we have with lemma,
let's at least understand what lemma says. So in this lemma, E is a vector bundle over X. This is correct.
yeah.
So, so the eigenvalues will depend on phi. And when you say that around the eigenvalues in the circle, this means X, the eigenvalues are multiple
Yeah.
is this correct?
Yeah.
So this
inside and outside it.
Outside the circle, one needs to check that these eigenspaces depend continuously on
Yeah.
X. This is sort of deletable.
Yeah.
This doesn't mean anything, but the statement is false. Anyway, that's
Yeah. Okay. Now we use lemma for e z plus e of x. So proof proposition 3. It's equal e plus z plus e plus of x what's meaning b plus of x and b minus of x is a restriction to e plus and e minus. B plus and B minus is a restriction to a restriction of B to E plus and E minus. And
well, let's write this down. We don't write down what the notations that we use. Please.
Yeah. Okay. So B plus have of our definition have eigen values outside S1. So it's meaning the formal of homotopy z plus b plus of x is defined correct, and so with equal e plus b plus x, and we can write with like E1 E plus 1 since b plus of x is an automorphism. Okay, if we look with, we can see b minus of x has a eigenvalues inside S1, its meaning, we can write the homotopy z plus t by minus of x. So E equals minus, sorry, I minus z. And we look proposition. It was we want proof. We are eigen values of by minus of x lie inside S1. So we can write the homotopy z plus t by minus of x. Okay. So now we can proof of surjective of nu. The idea of proof is preceding our proposition. Take x and the product goes to so we know vector bundle over x product S2 have form AF. By using twist proposition, we can write EF E z minus m q, whereas q is a polynomial clustering function. And we can write with EQ tensor product H whereas H tilde or roof, yeah. H roof is a pullback of canonical bundle over S2. Tautological. Total. Okay. And for this we can use proposition 2 and write with equal the product H with minus m and E1 and the product yep. And now we write with by proposition 3 we write and now we write with using external products is equal minus and with expression meaning what mu of with equal E and F, so it's a proving of surjection.
Very well. Now we want to program to this map mu is also injective.
Yeah. For proof mu is injective, we shall construct map nu, which composition nu and mu equal 1. Okay. Okay, for construct nu, we need some formulas.
Mu will be a map from where to where?
Map from new map from okay of x product S2 goes to We want new equal radius.
So if we apply mu first, then we would like to have the identity of k max times the h by h minus 1 squared.
Yeah.
Well, so let's see how it works.
Okay. Now we need some formulas. First formulas. N plus 2e ln plus 1q. It's ln n plus 1 q is meaning is a linearization clutching function of q. When we say in this proposition the q less n plus 1. Is equals e ln q plus okay, two series. We will write matrix representation of ln plus 1q. Matrix representation of this is a matrix like 1, 1, 1, 1. Minus that, minus that. So we can see in the last time we discussed about matrix representation is
What are a, m, etc., a0? What are those?
is coefficients of q. If q have form a n z n plus we can see is a homotopy 1 0 0, and here is 1 minus z 1 minus z en a0, and we can see we can write is another summand, and with proof with statement. Second formula tell us n plus 2 e n plus 1 q by of the q equal n plus 1 e ln q plus e z. So to see this, we can write matrix representation of L n plus 1 Q of ZQ. Matrix is a linearization of polynomial. Right? Is it Q?
Well, this thing depends on Q.
Yeah.
Q
Its meaning Q is a polynomial, and we multiplying by that with polynomial.
Yeah, so we take a polynomial and multiply it by z, we get another polynomial.
Yeah.
So,
Yeah. This is
this makes sense.
Matrix representation is a 1 minus z, 1 minus z, 1 minus 0, and coefficients of Q. So we can define a homotopy like this. 1 we minus the last column for next column, and easy to see is a matrix of representation of with, because we can swap with row and easily see with. Okay. Now we have E1 and bundle EZ, and we want look his E plus minus splitting, and we see is very simple. Okay. E1 we have a splitting E plus is 0 and E minus is all E. EZ E minus is 0 and E plus is all E. Oh, I
Let's say to have an E plus and E minus, we need to have an homomorphism of a bundle on X.
yeah, is 1 and Z.
Here yes, but one if we take 1 eigenvalues of the identity map are on the unit circle.
Yeah.
This doesn't quite in the second case, I don't understand the statement that we have E plus and E minus, but these are defined only for endomorphisms of a bundle of variants.
Mm-hmm. Yeah.
Now, if in EZ, we don't have an endomorphism of a bundle of variants. We have an endomorphism of a bundle of X cross S1.
Yeah.
So the E minus and E plus in 3 and 4 are not clear to me.
Я понимаю, да, что...
И плюсы и минусы, они вообще были определены
Да, да, да.
признаков того, что было бы иксы. Значит, вот теперь давайте посмотрим, где запятая и 1. Ну хорошо, разделитель и гипотеза, конечно, да, но все значения не вот эти. Вот. В втором случае, значит, у нас вообще какой-то ждут, который гоморфизм не иксе, а на x вместо 3. Ну, там тоже можно сказать, что значит, иногда там есть значения, но они тоже все единицы. Когда на z,
Да, нет, да, да, это.
пойдет по окружности. Ну, вот как раз значит, попадает в эту линию. Поэтому возникает вопрос, значит, что все это значит. So, my suggestion is let's have a break and maybe during the break we'll be able to figure out what's happening. Well, normally I would ask if there are any questions, but